In this lesson, we're going to look at how to use Snell's law to solve for the refractive index of an unknown liquid. In the lab, we're going to use clove oil, water, and vegetable oil as our unknowns. The equation for Snell's law is n1 times the sine of angle 1 equals n2 times the sine of angle 2, where n1 is the refraction of the unknown liquid, n2 is the refraction of air, which is a constant of 1.0003. You need to memorize that number. Angle 1 is the angle of incidence where the laser was held at in our lab. If we look at, the word incidence, you can remember this is the incoming light, so that you can remember that as angle 1. And then angle 2 is going to be the angle of refraction, or the angle of the light that's going out of the liquid medium. If we look at our diagram, this shape here represents a protractor so that we can measure the angles. And down here at the bottom of the page where my pointer is, would represent where the laser beam is going to be shown through the liquid medium. Here we would have our petri dish of our liquid. We would shine the light through, and this would be the angle of incidence, okay, the angle of the light hitting the liquid. And then this line shows that the light changes direction because it travels through this different medium and is going to then travel through the air. So depending on the liquid and the density of the liquid, the light is actually going to travel at different directions, causing the beam to come out at different angles on the other end. And the angle that this beam now is traveling by would be the angle of refraction, or angle 2. Okay, so it's the angle of bent light, if you will. Then if we take our protractor, measure the angles, we would get 30 degrees here as our angle of incidence, or angle 1, and our angle of refraction would be 45 degrees. Then we can just take those numbers and plug them into all the variables, where n1 is what we're solving for, so that's unknown. n2 is our constant for the refraction of air at 1.0003. Angle 1, our incoming angle of incidence, is 30 degrees, so incoming angle, that's 30 degrees, and angle 2, our angle of refraction, is 45 degrees. Then we just have to plug the numbers into the equation, which I have written for you here already. So then we get n1 times the sine of 30 degrees equals 1.0003 times the sine of 45 degrees. And we plug those into the calculator, and we get the sine of 30 being 0.5 and the sine of 45 degrees being 0.707. To solve for n1, we need to divide by 0.5 to get n1 by itself. Those two cancel out, and we plug these numbers into the calculator. Make sure you put 1.0003 times 0.707 first, and then divide that by 0.5. And our number is going to be 1.41. Bring your numbers out to the hundredth place. There are no units for refractive index, so please don't add any, and your answer would just look like that.